Solve the rational inequality. Write your answer in interval notation. Here I have x plus 11 times x minus 6 all over x minus 2 is greater than or equal to 0. So to solve this, the first thing that I need to do, because it's already in factored form, is identify its zeros. But I need the zeros both of the numerator and of the denominator as well. And in terms of changing signs from positive and negative, those are treated the same here, even though we know that zeros of the numerator are x-intercepts and zeros of the denominators are asymptotes. So the zeros of the numerator, if I just take each factor, like x plus 11, set it to 0 and solve, I get negative 11 and positive 6. The 0 of the denominator is positive 2. And the only thing that I have to pay attention to is that 0 in the denominator. I cannot include it as part of the final answer. So what I will do here, start a number line and place these zeros on it. So negative 11 is the smallest, it goes first, then 2 and 6. Now, negative 11, because we're looking for values that are greater than or equal to 0, is going to be included, or it can be included. So I'll put an open circle there. It is equal to 0 there. Then 6 as well. But 2, being an asymptote, cannot ever be included. So I need to make sure I put an open circle there. So no matter what we're looking for here, greater than 0 or greater than or equal to 0, 2 would never get included. Now I just need to pick some test values on each interval and see what's happening within each interval. So negative 12 is on this first interval, 0 is on the next, then 3 and 7. So if I take negative 12 and plug it into my rational, negative 12 plus 11 is a negative value. Negative 12 minus 6 is also a negative value. Negative 12 minus 2 is also negative. Now the product or quotient of 3 negatives results in a final answer that's negative. So everything on this interval is less than 0. Working with 0, if I plug that in, I would have a positive value times a negative value, and 0 minus 2 is also negative. So 2 negatives results in a positive answer. 3 plus 11 is 14, so that's a positive value. 3 minus 6 is negative. 3 minus 2 is positive. So the result there is a negative answer. Then 7, I have positive times positive over a positive. So the result is positive. So the values that are greater than 0 are the positive ones. So I need to shade in the intervals with positive solutions. So my final answer here is the set of numbers from negative 11 inclusive, because of that closed circle, to positive 2 exclusive, and then from 6 inclusive to positive infinity.